This video will focus on a learning target. I can describe the process for covalent bonding. So again, to revisit, what is a bond? It's that electrostatic force of attraction holding atoms together. And again, energy is released when that bond is created. So nature tends to be lazy and default toward a situation which is lower in energy. So compounds are formed because there's this degree of stability. There's energy released when two elements come together into a force of attraction with one another. The type of bond then, whether it's ionic or covalent, it depends. It depends on the atomic relationship between the two atoms that are bonding. So the deal with a covalent bond is that as two atoms get closer and closer and closer to one another, the electrostatic force of attraction between the nuclear protons and the valence electrons starts to occur between adjacent atoms. So on the screen you see two hydrogen atoms far apart. And as they come close to one another, that second picture up there on the far side where it has those dots, you can see those dots are electrons. And as the hydrogens come close together, those electrons are being drawn towards the two nuclei of the two adjacent atoms. And essentially, depending on the relationship here, as those electrons are drawn, depending on the magnitude of the nuclear pull, you could have an ionic situation where we have a full transfer of electrons. But in a covalent situation, what happens as they come together is both nuclei are drawing electrons. And so as they come together, there's a force of attraction that pulls them together. And eventually, when they get too close, then there's a force of repulsion of their two nuclei. And it's sort of that perfect balance between the push and the pull that gives us our covalent bond. So covalent bonding is two atoms as they come close to one another. Rather than an electron being transferred, we find a sharing happen. The electrons are being shared in order to get to the s2p6. So when we covalently bond something, again, that's a sharing. And we share pairs of electrons always because we have completely filled orbitals. Different than ionic because instead of those crystal lattice structures where they form crystals, these guys form discrete molecules. So they are a particle in themselves. They have a new identity and they move together like in a uniformed group, essentially. So opposed to ionic also, where ionic had something that liked to pull well with strong effective nuclear charge and something that easily gave up electrons, low ionization energy, and they transferred. Covalent bonds instead tends to be with two things that are both seeking electrons. So you have something that pulls really well, coming up with something else that pulls really well, and when they come towards one another, there can't be a transfer happen anymore, so instead they figure out how to share. And how they share depends on the number of valence electrons that the atom contains and how many they are willing to share. Okay? With ionic bonding, we usually say it's a metal and a nonmetal that's coming together to make that salt because the nonmetals are those high electronegativity and the metals are those low ionization energies. For covalent bonds, it tends to be nonmetal with nonmetal, so two that are high in electronegativity. When that happens, we actually have a melding of orbitals, these two red dots, the two nuclei, but now you can see how their outer orbital where the electrons reside actually overlap. Okay, that's the process of covalent bonding. You actually have a melding together of orbitals for electrons to be shared. So if you look at the simple case of fluorine bonding with fluorine, the fluorine has basically 7 electrons in its valence shell and wants one more. And what happens right there, those two unpaired electrons in fluorine come together and they come into an overlapping orbital between the two fluorines, and those are the two electrons that are being shared. So the reason the two atoms are being held together then is because there's a force of attraction between all the electrons and the nuclei. So the electrons on this fluorine over here are attracted to that fluorine, and the electrons on this fluorine over here are attracted to that fluorine. And now we have this electrostatic force that's holding them together. These molecules are neutral. There has not been any transfer of electrons from one to the other. Rather, there's just a share, opposed to ionic, where you actually make full ion charges. That's it in terms of the process of covalent bonding. Have a nice night.